if this matrix that has 3 rows and 1 column is equal to this other one with 3 rows and 1 column, then what's the value of this expression, 2x minus y plus 3z? So just to kind of open your thought process here, if I had a matrix that looked like this, smiley face, frowny face, and the number 6 is equal to fish, I'll do, let's see, fish will be the second element, and this will be 20, this will be -2. Just to make them the same, there's probably a lot that you can tell me, right? Like, one thing you could tell me is, well, what would need to be here to make them equal? And even if you don't know what a matrix means, you would probably say smiley face 6, frowny face, right? Because you know that to be the same, they have to look the same. And so what I'm saying is, well, but this is what was originally there. The 20 was where the smiley face is, the fish was where the 6 is, and the -2 is where the frowny face is. So smiley face must be the same as 20, 6 must be the same as fish, and -2 must be the same as frowny face, right? Because they're just in the same spots, right? If I take my original, put it back. If matrices are to be equal, then each individual element must be the same as its corresponding one in the same position. So, like I said, smiley face would have to be 20, 6 would have to be fish, frowny face would have to be -2. So likewise, we have corresponding elements here, and those must be equal to each other for the whole matrix to be equal to the other one. So x minus 3 must be the same as 0. So for what value of x is this true? What minus 3 is 0? Well, whenever you're subtracting 3 away from something, what could I take 3 away from to make it 0? Hopefully you could figure out this was 3. So x must be 3. Likewise, y minus 5 equals 1. What can I take 1 away from, or 5 away from to get 1? 6. So y is 6. And 2 times a number is 4. 2 times a what is 4? 2 times 2 is 4, so z must be 2. So now that I have these values, I can substitute them to evaluate this expression. So 2 times 3 minus 6 plus 3 times 2. Well, 2 times 3 is 6, minus 6 plus 6 is 6. So I can use this matrix, the equality of matrix of matrices, to find missing values and then use that to evaluate expressions. Remember, if they are the same dimensions, now if these were not both 3 rows, 1 column, 3 by 1s, then it would be harder to determine what to do. But because they are the same structure, the same dimensions, and when they're equal, that means their corresponding elements must be as well.